So your MT is over. Can you hear me first of all? Can all of you hear me? Let one respond. Is it
Sir,
audible? Can you all
Yes,
of you
sir.
hear? Okay. Okay. So shall I start the class or wait for some time?
wait একটুখানি হয়ে যান।
সবাই তো এমটিএ তো ভালো করেছিস। Congratulations to all of you. Uh, so I'll be starting with a new topic today. A new chapter because thermodynamics is over. Chemical kinetics is taken care by that faculty. So I will be concentrating on the next topic, that is your acid base and uh, electrochemistry together. Acid base, equilibria, and electrochemistry. Today will be the introduction class. Thereafter, we'll be having tomorrow also, if possible, we'll be having the class. I don't know if you have the time. So, as you know, that the classes shall continue till 14th of the next month, and I don't know how much it will be possible to complete the syllabus, but till 14th of the next month, whatever we complete has to be incorporated in the syllabus. This is number one. Let's make a point that whatever the syllabus that we complete, already we have completed two of the units, mostly two of the units. I don't think so. You should take much more time for chemical kinetics. Now the approach of our study should change because had it been a subjective type of question, my approach would have been different. Now the approach is slightly is changed for this semester. Since because it will be all MCQ pattern of question, so mostly it will be based on numericals on the paraphernalia of understanding the theoretical portion. If you understand the theoretical portion, then mostly there will be numericals. It will be only the numericals that will be mostly you have to concentrate. And little amount of theoretical also, some tricky questions that will be asked. Had it been a subjective question, you should have gone for the derivation. Now there is no requirement of the derivation. Only the thing that we require is to understand the concept of the particular chapter, and then can I log the meeting? Disturbing me. So hello, hello. Can you hear me?
Yes, sir.
Okay, I have logged the meeting. So the point is now our approach has to be different. We do not encourage those derivations. When I start with acid base equilibria, now what you understand by the term equilibria? What shall we study in acid base equilibrium? The first thing that we are going to study is some numericals related with the degree of dissociation. So we are going to study Ostwald dilution formula. We are not going to, question is not going to ask to derive the Ostwald dilution formula. But from the formula itself, we have to understand the importance of this formula in solving the numericals. This is number one point. Number 2 point is we are going to study the numericals related to the pH and to find out the hydrogen ion concentration from a given ionic solution, as well as to understand the hydroxyl ion concentration, to calculate the hydroxyl ion concentration. We have to know what is the dissociation constant of water or ionization constant of water, and find out the probable reason that why the pH of the water is 7, or rather we have to find out the answer that why the pH scale Why it is divided to up to 14? That is the very simple thing, and this is very easy. Then we are going to learn about Henderson-Hasselbalch equation when we come to the salt and salt hydrolysis. From salt hydrolysis, we move to the transport number, and then we move to the electroconduction. Conduction. There is very little scope of understanding Debye-Huckel's theory. And once the Debye-Huckel's theory is finished, we slowly migrate towards an electrochemical cell, designing of electrochemical cell. We all know that what is the oxidation reduction, so I skip that portion. Obviously, it will come under discussion. And once this Debye-Huckel's theory is finished, transport number is finished, then we also discuss Corlos law of conductance, specific conductance, then molar conductance, the reason for the molar conductance of high for the mineral acids. And then we move towards the electrochemical cell to find out the EMF of the electrochemical cell, Nast equation, and then again thermodynamic feasibility of an electrochemical cell. And we will study 2-3 electrochemical cell along with the batteries and the lithium-ion battery. Most probably we'll study polymer batteries. Now electrochemistry, electrochemical cell has become now polymer cell. So we will be studying all these aspects and to complete the whole unit. So to start with, what is an acid? Acid. Can you see the whiteboard? Can you see the whiteboard?
Yes, sir.
Yes, sir.
So if I so what is an acid? Can anyone tell me? How to make it black? What is an acid? How do you define an acid? What is the different definition of an acid? Please tell me quickly. So there are two different concepts of acid. One concept is which is based on Arrhenius concept. Arrhenius concept of defining the acid. What does this concept say? It says that the acids are those which are hydrogen donor or which can release hydrogen. He also said the strength of acid is equal to number of hydrogen replaced or given up. Now, accordingly, if we see, we know basically there are two types of acid. One is called mineral acid, and the other one is called organic acid. Now, under mineral acid, what are the things that comes? Mineral acids are mostly H2, H2SO4, sulfuric acid. So it is, I can write it here, sulfuric acid, hydrochloric acid, and phosphoric acid. These are all different type of mineral acids. What is the specialty of this mineral acid? Can anyone tell me? And the organic acids are mostly the primitive organic acid is acetic acid. the distinction between the two, mineral acid and organic acid. What is the difference between mineral acid and organic acid? Mineral acids are also known as inorganic acid. What is the difference between mineral acid and organic acid? No, so if you remain mum, it will be very difficult for me to go through. What is the difference between mineral and organic acid? What is the basic difference between mineral and organic acid? Yes. Yes, Animesh. What is the difference between mineral and organic acid? And all of you see? Hello? Yes, Animesh.
Sir,
Yes, Animesh. I am speaking to Animesh Banerjee.
sir,
Yeah, tell me.
the main difference between organic and mineral acid and organic acid is that mineral acids are composed of different chemical elements, and organic acids are composed of carbon and
No.
hydrogen atoms.
With respect to acid base equilibrium theory, what is the main difference between mineral and organic acid? The main difference between the mineral and organic acid is no, Giresh, this is not right. With respect to, so if this question comes and if there are 2-3 multiple choice, then the correct answer is there dissociation pattern. Which dissociate faster? More is the dissociation, more or quick is the dissociation. More is the release, quicker is the release of hydrogen ion. Quick is the release of hydrogen ion. So now, so the difference is that the dissociation product. More of the quick is the dissociation. Quick is the release of the hydrogen ion. So here, the mineral acids have high dissociation pattern as compared to any organic acids. Now, why mineral acids have more high dissociation pattern? If you see any mineral acid, what is that mineral acid? If I write here like this HHSO4, what is this? This will dissociate into H plus, sorry, it will be in the superscript. I cannot write in the superscript. Plus, it will give you what? First of all, it will give H plus HSO4, sorry, 4, that is minus, HSO4 minus. So this is one dissociation pattern. The second dissociation pattern is further taken as HSO4 minus. Further it dissociates into again H plus S, sorry, SO4 minus. So thus it gives you in total it gives you how many hydrogen? It gives you 2H plus. That means this, as it gives you 2H plus, this is a diprotic. It's a diprotic acid system. And the process by which the dissociation, the process by which the pattern of dissociation is followed is called auto is called autoprotolysis. So underline this word, autoprotolysis. This is very important word. It is, sorry. So this is an autoprotolysis.
Sir, meaning of autoprotolysis?
It means auto means step by step or automatically. Auto means automatically. Proto means proto comes from the word actually hydrogen ion. Hydrogen ion, and lysis means breakdown. And lysis means break down. Sorry, breakdown. So this is called the autoprotolysis. Now here the most important point that I need to discuss is the dissociation pattern or the dissociation. Now if I take an organic acid, what is that organic acid? If I take an organic acid, suppose an organic acid is taken. Can you see the thing? Is it? Can you see it? Hello students, can you see it?
Yes, sir.
Now if I take an organic acid, for example, an organic acid is suppose an acetic acid. Now what happens if I compare this with the acetic acid? Now acetic acid is also known as vinegar. It is a household name and it's an organic acid. What is the formula? It's a carboxylic acid with an alkyl group. So it becomes, you have CH3, sorry, 3, then COOH. Now when it dissociates, what it gives you? It gives you CH3, sorry, 3 plus what does it give you? COO, this is negative, plus H plus. Now you see why. What is the difference? Here I am not writing, whenever I am writing an organic acid, I am not writing autoprotolysis. But if you see over here, there is autoprotolysis is because there is one H plus, there is another H plus. This H plus totally goes broken down in the second step to give you total 2H. But now if you over here see, This is the electron affinity. That is called, this is the electron affinity because oxygen is a highly electron cloud density. It has a high electron affinity towards the H plus. Hydrogen always tries to drift the electron from the H to the oxygen. That is why H is getting positive charge because of lack of electron. And oxygen getting excess electron due to which is getting negatively charged. Now this electrostatic force of attraction between two opposite charge does not release the hydrogen so quickly into the solution, and that is why its dissociation sorry its dissociation constant is poor or weak, and hence it is a weak acid since its dissociation constant is poor or weak, hence it is a weak acid since its release of H plus is feeble. Have you understood? Or shall I need to understand
Sir,
very
please
deeper?
repeat. Sir, please repeat.
Which one?
That electron density or electron cloud one.
This is called negative inductive effect. What happens because of this CH3COO negative, the electron cloud over the oxygen is high, and due to it, it is getting the negative charge. Excess electron cloud is giving a partial negative charge on the oxygen, and as hydrogen also has its electron initially. Now, when it starts ionic dissociation, the electron drifts from the hydrogen towards the oxygen. Since oxygen has more higher electron affinity, so it takes away all the electron from the hydrogen, and the hydrogen gets positively charged, whereas oxygen has the excess electron. Due to the excess electron pool, the attraction or the degree of attraction, that is the electrostatic force of attraction between the oxygen and the hydrogen, becomes intense. And due to its intense electrostatic force of attraction, it does not release the hydrogen easily or quickly or very fast. It releases slowly. That is why I have written the release of hydrogen. There is a slow release. I'm writing over here once again. There is a slow release of hydrogen ion, and hence it is a weak acid. Now, I hope each and every one have your copy. Now, if I see the equilibrium, or if I want to establish the law of mass action, what will be the law of mass action? So, according to the law of mass action, do you know law of mass action? So, what is the law of mass action? That is the concentration of Again, I'm writing. Is divided by the concentration of so this is equals to, or this is equals to, now I'll write one constant, that is your, this constant is K. Now this constant, if it is an acid, if it is an acid, if it is an acid, then this constant is represented as K, and in the suffix small a, which means it is the dissociation constant of an acid. If I take the dissociation constant of a strong acid, now here this is CH3C and H plus. Now for numerical, please try to understand. If you are given a numerical in which it is saying that the equation is of an acetic acid, suppose the initial concentration of the acetic acid is X mole per liter. This is very important. Suppose they have written, can you hear me? Can all of you hear me? This is
Yes,
very much
sir.
important. Please write down in your notebook. If suppose there is an X mole per liter, concentration unit is mole per liter. If the concentration of a acetic acid is given X mole per liter, and the dissociation constant of an acetic acid is given, and they say you to find out the concentration or the pH of the solution, then what will be your answer? For example, now if I go to the numerical and let me write
Can you
down,
please repeat the question again?
I'm writing it down. Can you help me out to erase it out? This is the erase. Just give me 2 minutes time. Let me erase it. So if I say the question is like this, calculate the hydrogen ion concentration of calculate the hydrogen ion concentration of a 0.06 molar acetic acid solution that undergoes dissociation with a constant of 1.8 into 10 to the power minus 5. 1.8 into 10 to the power minus 5. So how are you going to solve this numerator? Can anyone do it? Calculate the hydrogen ion concentration of 0.06 molar acetic acid solution that undergoes dissociation with a dissociation constant of 1.8 into 10 to the power minus 5.
Sir, 0.108 into 10 to the power minus 5.
This is the dissociation constant. That is the Ka value. Remember always, if the question paper does not give you the dissociation constant, make it to note that the dissociation constant of an acetic acid is 1.8 into 10 to the power minus 5. I will not repeat the same thing in every class. The dissociation constant, it is experimentally proved that the dissociation constant of acetic acid or vinegar, whatever you say, is 1.8 into 10 to the power minus 5.
Sir, answerটা কি 0.108 into 10 to the power minus 5?
I have not done it right now. How have you proceeded?
Sir, with the formula H equals to C alpha, where C is the concentration, means molar concentration of the
alpha?
solution, and alpha
Where is
is
the
the
alpha?
dissociation constant, sir.
No, alpha is the degree of dissociation. It is the number of the solute dissociated divided by the total number of the solute.
Okay, then sir, the formula H plus equals to root over Ka into C, where K is the degree,
What is H?
dissociation constant.
What is H?
H is, sir, the concentration of H plus ion.
What is H? H is the hydrolysis, right? H is equal to square root of Ka into C. That is again Ostwald. Here, this Ostwald dilution formula is not going to be approved. Only the thing is that you have to this formula that CH3. Suppose if I write COOH, when it dissociates, it gives you three C double bond O negative plus H plus. Now let the initial concentration at time, sorry, let me write from much more from here. At time t equals to 0 minute, let A be the initial concentration. Let A be the initial concentration of acetic acid. At time t, so t minute. Now what it will become? Hello? Hello? Yes? Hello? Now tell me at time t, can you hear me? At time t equals to t minute, what will be the thing? Now acetic acid is a weak dissociation and it will slowly go on dissociate. So the whole, suppose x is the amount of the amount of the acetic acid, amount of acid remain undissociated, then at time t to t minute, the leftover is a minus x be the leftover amount. Now the most important point is the concentration of acetic acid is 0.6 molar concentration. When it dissociates, it will get, let x be the concentration of, let x be the concentration of acetate ion and hydrogen ion. Therefore, K equals to, we know K equals to concentration of CH3, sorry, divided by the concentration of CH3 COOH. So therefore we can say that K value is, what is the K value? K value is 1.8 into 10 to the power minus 5, that is equals to x square divided by 0.6 molar. From here you calculate the value of, now once you calculate the value of x, you get the concentration of hydrogen ion. Please calculate. Hello. 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 Can you hear me? Can
Yes,
you hear
sir.
me?
Yes.
Please calculate. Now, any question in this? I think there will be several questions. I expect questions from all of you. This is the main thing that we need to understand. I want many questions from your end. If you are attending the class, you will ask question. If you are not attending the class, you will not ask question. Remember, these also have marks. You calculate what is the value of x. What is the value of x? Hello? Hello? What is the value of x? What is the value of x?
1.08 into 10 to the power minus 5.
It remains the same?
Sir, yes. Yes,
Tell
sir.
me the,
Remains the same with my formula.
so the value of x is 1.08
1.08 into 10 to the power minus 5.
10 to the power minus
Minus 5.
5. Sorry. Is it correct? I have written. This is the
Yes,
value?
sir.
Okay. Now, do you have any query?
No, sir.
I expect many queries. Why it is x square?
Why it is
Ah.
x?
So we have taken the let X be the concentration of
So why should
CH3.
be why should be the concentration of acetate ion hydrogen ion be x into x? Why should it be x square? Why it is not x into y? Why both are equal? These are all the things we need to understand.
Because they're due to the balancing factor.
No, anyone who can reply this?
So it has dissociated from a same molecule.
No. Who says this?
So me, Shweta.
It differs. It arises from the. Repeat your answer, please.
So that uh,
Repeat.
so we have taken X,
You are
the
very.
concentration of both CH3 COO minus and H plus ion because it has dissociated from a same molecule.
That's what. Because this is the one of the reason that it is not. It's a unimolecular. It's reacting from the same moiety. And why should it be equal? Why should it be equal? Even it is dissociating from the same moiety, when it is dissociating, it may happen that acetate ion concentration and hydrogen ion concentration at a time may be available, or acetate ion concentration may be available. It may be equal, but the timing of the concentration are also at the same point of time. That is why only you can quantify the concentration of the acetate ion as well as the hydrogen. Now, the second question is that why is it that? Because it is arising from the same molecule. That is why we are saying it is dissociating in a equimolar concentration. That means whatever this acetic acid will dissociate, it will dissociate into this concentration equimolar and this concentration equimolar. Now, if I say if this question is asked with respect to same thing 0.06 molar, but if it is asked with respect to H2SO4, can I consider the same concept? Can I consider the same concept?
No, sir.
Why? Then what makes the difference between over here?
Sir, in H2SO4, two H plus ions are
Let
dissociated.
it be. So what? Let it be 3H or 4H. We are going to take only one H, so we'll divide by 4.
So it is not equimolar anymore.
It is not equimolar, but why it is not equimolar?
Balance due to.
No, I wrote something in the beginning of the class. Because H2SO4 is a highly dissociable. It does not dissociate slowly. That is why it is
Yes.
not equimolar. The most important reason is with respect to acetic acid. Acetic acid is a very weak acid. It takes time to dissociate. That means its dissociation is taking on, but is very slow process. due to which there is always there will be release of acetate ion and hydrogen ion. So at any point of time, you measure the concentration of the acetate ion or hydrogen ion, it will be equimolar. That means I can say what will be the concentration of the acetate ion will be the concentration of the hydrogen ion, or else in the other words, whatever will be the concentration of the hydrogen ion will be the concentration of the acetate ion. But that is not the case with any type of mineral acid, be it HCl, be it phosphoric acid, be it sulfuric acid. Did you understand?
Yes, sir.
The same thing, the same concept goes with a weak base, not with the strong base. The same concept goes well. This type of numerical goes well when we are concentrating with weak acids and weak base, not with strong acid and strong base. Now, if I say sodium hydroxide, what sodium hydroxide is? Is it a weak base or strong base?
It's a strong base.
It's a strong base. Why it's a strong base? Again, there might be one reason. Because if you see, it's a metal ion. It's the metal ion which is conjugated with an oxygen. So that is a metallic ion is bonding with the hydroxyl ion, OH ion. So it's a strong base. It releases the basic OH negative very fast into the solution. That is why it is a strong base. So those which can release the hydrogen ion or hydroxyl ion, they are said to be the strong acid or strong base. This was the concept of the Arrhenius concept. Shall I give another 2-3 numericals?
Yes, sir.
Okay, please hold on. I am bringing one book. Just give me 2 minutes time. I'm just finding out the question. Okay, write down the question, please. Can you hear all of you? All of you can hear me? Hello?
Yes, sir.
Hello, can you hear me?
Yes. Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Okay. So I'm saying please write down the question. Calculate the molar concentration. This is question number 1. Calculate the molar concentration of an acetic acid solution. Calculate the molar concentration of an acetic acid solution which is 2% ionized. Which is 2% ionized. The next question. Hello?
Yes, sir.
Calculate the molar concentration of an acetic acid solution which is 2% ionized. Have you written this one?
Yes, sir.
Okay. Next question, please. What is the OH ion concentration? What is the OH ion concentration of a 0.2 molar solution? What is the OH ion concentration of a 0.2 molar solution of NH3 plus, of NH3? Given, given, given Kb equals to, that means Ka is the dissociation constant of the acid, Kb is the dissociation constant of the base, and Kb equals to 1.8 into 10 to the power minus 5 equals to 1.8 into 10 to the power minus 5. We are taking the same value of the K and Kb.
Can you repeat this question once more?
Which question? The second one. What is the
Sir.
OH ion concentration? What is the OH ion concentration? OH ion is OH negative ion concentration of a 0.2 molar solution of a 0.2 molar solution of NH3 of a 0.2 molar solution of NH3. Given Kb equals to 1.8 into 10 to the power minus 1. Given Kb equals to 1.8 into 10 to the power minus 5. Have you got? I have given two questions. Can you solve this question, please? I am waiting for you. Hello.
Yes, sir.
Please solve. I'm just holding the class. I'm just coming. You please solve these two questions. I'm joining within 2 minutes. নতুন নাটক অনেক রাস্তায় চালাই তো আমার কথা খুব বেটার হচ্ছে ওরা ওদের তো কষ্ট আমাদের আরো বেশি কষ্ট হচ্ছে ওদের ছেড়েই ওরা ছেড়ে দিলে ওরা নিজেরা জানে না যে জল চালানো থেকে জল ছেড়ে দিলে আরেক বেশি উপকার হবে ওরা যত ছেড়েই কি হবে আমাদের বাঁধবে তাই না হ্যাঁ ব্যবস্থা হয়ে যাবে আমরা থাকতে না আমরা খেলতে না পারা যাচ্ছে ওরা ছেড়ে দিচ্ছে কষ্ট থেকে আমাদের বেশি কষ্ট হচ্ছে জল আছে Hello, have you solved the problem?
Yes, sir.
Did you solve the problem?
Sir,
Tell me
first
the,
one is one.
tell me the answer.
Sir,
Sir,
first,
zero,
sir,
zero
first
point,
one, 0.0375 molar.
0.0375.
Molar.
Which one?
Sir, first
Number
one.
1, sir.
That is the calculate the molar concentration of acetic acid solution, which is 2% ionized.
yes, sir.
Yes, sir.
What
Yes,
is
sir.
what is the answer?
0.0375 molar.
Yes, sir.
0.0375.
75.
Okay. How have you done it? It is saying 2% ionized.
Yes, sir.
How have you done it?
So,
Have you done in this way? Let me show you. Your answer is wrong because it is saying 2% ionized. You have to consider 2% ionized. What does this 2% ionized means? It means 2 divided by 100. That is equals to 0.02. Okay. Now I said that you will consider x. So this is x. Now this is multiplied with another 0. This is multiplied with another. This is the concentration of acetic acid, and another concentration of hydrogen ion is 0.02 x. Now this divided by the what is it is divided by x. X is the initial concentration of acetic acid. This is the 2% ionization constant or ionization of acetic acid. So the percentage of acetic acid that is ionized will be the concentration of the acetate ion, which will be equal to the concentration of the hydrogen ion. And the initial concentration of acetic acid was X. And now you have to compute this according to this formula, because already we know that K value is given. We know that I'm writing the formula. It is CH. Sorry, it is CH3 COO negative into H plus divided by third bracket CH3 COOH. Now this becomes K value is given how much? What is the K value? It is 1.8 into 10 to the power minus 5, that is equals to 0.02 x. Now if I put within bracket, this is 1, this is multiplied with another, this is for acetic ion, this is multiplied with another 0.02 x. This is divided by x. Now when you compute, you get the value of x. So after computing, how much will be the value of the x? Please compute. What will be the value of x? This is how you have to do the numerical. I think it will be 0.045. This is the concentration of have you understood? Hello? Hello? Have you understood?
Yes, sir.
Now the next question. What is the OH ion concentration of a 0.2 molar solution of NH3? The same way. Again the same way. So this method is again, so you have to write over here the reaction of NH3. First of all, to deduce all this type of numerical, you have to write down the the reaction or the ionic reaction of this. So what is it says? NH3. Now it dissociates with water, H2O. Now it gives you, what does it give? It gives you NH4 plus ammonium ion, and this is conjugated with hydroxyl minus. This is the whole ionic equation. From here, we can write that the dissociation constant Kb, that will be equals to concentration of NH4 plus third bracket close multiplied by concentration of OH minus third bracket close divided by the concentration of NH3 third bracket close. The Kb value is given as 1.8 into 10 to the power minus 5, that is equals to x square, because ammonia is a weak base, so the concept remains the same. So it becomes x square divided by, so it becomes x square divided by the concentration of ammonia. The concentration of ammonia is what is the concentration? Is 0.2. From here you have to compute the value of x. So x will become how much? Find it out, please. What is the value of x? Hello? Hello, have you done it?
Sir, its value is x equals to 0.00189.
So I can write the value. If we say 189 is 1.9 into, so always in the exam it will not be given in this way because it's a dissociation constant. It will be given 1.9 into 10 to the power minus 3 molar concentration. Am I correct?
Yes, sir. Yes.
Am I correct? Now, these are the type of numericals that you have to face. So today we have learned. Now, what is the definition of dissociation or degree of dissociation? Someone was talking about degree of dissociation. Now, when I say degree of dissociation, it is nothing but it is the ratio of number of solutes dissociated, the number of the solute dissociated to the total number of solutes present. Total number of solutes present. So that is given by, it is represented by alpha. alpha is the, sorry, alpha. So I can say that alpha is the so alpha is the degree of dissociation for an acid, whereas beta or it is alpha, it is said alpha A or alpha, you can write rather in the higher textbook it is written alpha within bracket A stand for is the degree of dissociation of an acid, whereas alpha B, sorry, is the degree of dissociation of an base. Did you understand? So this you have to write in a symbol because I cannot know how to write over here. So this has to be written in a symbol. Now in these two numericals, so what in the two numericals, what will be the degree of dissociation in the second numeric? So find out the degree of dissociation in the second numeric. Hello? Hello? What will be the degree of dissociation in the second numeric? Hello, are you there? Hello? Hello? Hello?
Yes, sir, calculating.
So, alpha will be, that will be equal to total number of solids dissociated. So number of the solids dissociated is 1.9 into 10 to the power minus 3 divided by total number of the moles that is taken is 0.2. This will be your degree of dissociation. Mole, this is also mole. So both of them will get removed. So it will, and degree of dissociation does not have any units. It is only the ratio. So what is that? This after calculating, what will be the answer?
So 9.5 into 10 to the power minus
10 to
3.
the power minus 3.
1.5.
Sir, 9.5.
It is 9.5.
Yes, sir.
Yes, sir.
Okay.
Into 10 to the power minus
9.5 into
3.
10 to the power
Minus 3.
minus 3. This is your degree of dissociation. The last numerical for today's class, I am giving you another numerical. Calculate the percent ionization of 1 molar solution of 1 molar solution of hydrocyanic acid, 1 molar solution of hydrocyanic acid, HCN. Calculate the percent ionization of 1 molar solution of hydrocyanic acid.
Sir, hydrocyanic.
Calculate the percent ionization of, if I write in HCN, this is called hydrocyanic acid of 1 molar solution. This is the question. Calculate the percent ionization of HCl of 1 molar solution. So the answer to this, first of all, we'll write HCN. This is dissociate into
H plus and Cn minus.
it dissociates into H plus plus Cn minus. Now, what will be the dissociation constant? It is Ka will become third bracket concentration of H plus into concentration of minus divided by the concentration of HCN. Sorry, it will become third bracket. So Ka value is not given. So you write down the Ka value is 6.2 into 10 to the power minus 10. The Ka value is 6.2 into 10 to the power minus 10. That is equal to
Hello, sir. Your voice is not coming.
the, even if my voice is not coming, I am writing on the board. It is 6.2 into 10 to the power minus 10. That is equal to, so again hydrocyanic acid is a weak acid. So here again it will become x square divided by the 1 molar solution, because it is given 1. So I will take 1 molar is the concentration. So from here we have to calculate the value of, first of all we have to calculate the value of x. Kindly calculate the value of x. Calculate the value of x quickly.
There is 2.49 into 10 to the power minus 5.
So approximately, I can say approximately it is 2.5 into 10 to the power minus 5. Am I right?
Yes, sir.
Okay. Now we have to find out the degree of dissociation, that is alpha. So alpha, that will be equal to, that is equal to the number of the solutes ionized or ionized HCN divided by total HCN. So from here we can find out the alpha. Alpha shall be equal to, what is ionized HCN value? Ionized HCN value is 2.5 into 10 to the power minus 5, sorry, divided by total HCN value is 1. So all the units will be mole per liter because it's concentration in both the cases. This will give you a value. Now this multiplied with, now if you want to find out the percentage ionization, if we want to find out the percentage or percent ionization, this will be equal to 2.5 into 10 to the power minus 5 into 100. So it becomes, answer is 0.0025%. This is the percent ionization of HCN. I have written again, calculate the percent ionization of HCN of 1 molar solution. First of all, we did the equation or the reaction. HCN dissociates into H plus Cn minus. Now the dissociation constant is H plus into Cn minus divided by HCN. We take the Ka value 6.3 to 10 to the power minus 10. That is equals to X square because HCN is a weak acid. It dissociates into equimolar into equal concentration of hydrogen ion and cyanide ion. Let X be the concentration. So it becomes X square divided by 1. So approximately X becomes 2.5 into 10 to the power minus 5. From here we find out the alpha value, that is the degree of dissociation. It becomes ionized HCN divided by total HCN. So a ionized HCN value we get 2.5 into 10 to the power minus 5 divided by total HCN is 1, and hence from this calculation to percentage ionization we multiply by 100 and we get the answer 0.025 is your percent ionization. Is it clear to all of you?
Yes, sir.
Yes, sir.
Okay. Thank you for the class. I end the class over here. Thank you. Can anyone send me the attendance print in my mail ID because my WhatsApp is not working. I don't know what happened to the WhatsApp. Okay. Hello. Hello.
Yes, sir.
Okay. Tomorrow, can we take a class? Can we take a class tomorrow? Is it possible for you? Okay, I'll talk to Rajrupa tomorrow. Thank you.